The aim of experiment 6 of DSP lab is to compute instantaneous amplitude, phase and frequency using Hilbert transform. Here we can see we have taken the original signal as the amplitude modulated signal, where the carrier frequency is kept at 60 Hz and the sampling frequency is kept at 600 Hz. First we compute the Hilbert transform manually. So we know the Hilbert transform is equivalent to doing convolution with 1 by pi t, which when thought of in terms of frequency domain turns out to multiplying the DFT coefficients with plus j in case of positive frequency components and minus j in case of negative frequency components. So we first compute the DFT coefficients of the signal. Next, in order to find the Hilbert coefficients, we multiply with minus j and plus j respectively. We plot all the signals, and after finding the Hilbert transform in frequency domain, we do inverse Fourier transform to find the Hilbert transform in time domain. We can plot both the functions from inbuilt function as well as the MATLAB function, which is called the Hilbert, which gives us the analytical signal, and comparing the imaginary part of the analytical signal, we can verify that the waveforms received from both the mechanisms are accurate. Next, we calculate the instantaneous amplitude from the analytical signal by computing its absolute or magnitude. We find the instantaneous phase by taking the phase angle of the analytical signal, and after getting the phase, we find instantaneous frequency by basically taking the derivative of the phase. And next we plot all the signals to see the outputs. Here for amplitude modulation we can see the original signal, the frequency components, the manually calculated and inbuilt function and calculated using inbuilt function Hilbert transforms, and we can see the instantaneous amplitude, the instantaneous phase and instantaneous frequency. Similarly, we can do the same for frequency modulated signal as well. Here we can see that the information is modulated in the instantaneous frequency. Similarly, doing the Hilbert transform for exponentially decreasing function, we get the original signal and its frequency components, the manually and inbuilt function calculated Hilbert transforms, and the instantaneous amplitude, instantaneous phase and instantaneous frequency.